It's a closed box. Calculate the pressure of the gas. Use Provner. Yeah, we're good. R is what, 8.31. I got something like around 50 kilopascals, or around 5 times 10 to the 4th. Is that right? 1, 2, 3, 4. Yeah. There we go. Okay. When the gas is supplied with 0.86 kilojoules of energy, its temperature increases by 23 kelvins. The specific heat capacity of the gas is 3.1 kilojoules per kilogram per Kelvin. Okay, so this is an MCAT thing, right? And that 0.86 kilojoules, remember that's, kilo means times 10 to the 3rd, okay? That's your Q. This is your delta T. This is the C. So you can find the mass, right? The mass is not very much. It is, and I actually got this wrong. I set it up right, and then I couldn't clear fractions. Like I divided the wrong thing by the wrong thing. So it is around 10 grams. It is a fraction of a kilogram. Okay, it's around 10 just plain old grams. Okay, determining kilojoules the total kinetic energy of the particles of the gas. Okay. So, by the way, they mean when they do that, when they say that, because I did both answers, because I'm like, well, is it at 290 or is it at, right? But it's going to be at the new temperature, right? So the new temperature is going to be, what, 290 plus 23 is 313 kelvins, right? So how do you do this? The total kinetic energy of the particles in the gas, right? Don't we know that it's 3 moles? Don't we know that the temperature is 313 kelvins, right? We ought to be able to figure this out, right? So the formula is what? The average kinetic energy is 3/2. Let me find the right equation here. It's not one that I actually, what did I do? Oh, there it is. It is 3/2 times R over Avogadro's number, right? Times T, right? But that's a one particle, right? We're talking about, we want to multiply that by the number of particles, right? So that's going to be 3 moles times Avogadro's number, right? If you multiply that by this, right, so 3 moles by Avogadro's number, then you're set. Now notice that Avogadro's number cancels, right? So you end up essentially with the total internal energy being 3/2 nRT, right? N is 3, R is 8.31, T is 313. But anyway, and this formula is in the section, the last option section. We don't have to take the test on it, but it's helpful. This question, though, comes from paper 2, right? And so they expect you to be able to do this even if you didn't study thermodynamics, and we're not going to study thermodynamics, right? Okay, so then it says, explain with reference to the kinetic model of an ideal gas how an increase in the temperature leads to an increase of pressure. Let's see if you can do it. What does temperature mean, right? What is it when you increase the temperature? What are the particles doing? How do they exert pressure on the walls of the container? This is an important concept. What is that pressure? How does a gas push on the walls? Why would whatever happens when the temperature increases increase whatever that is, right? Okay. Woohoo. There's actually a couple things that go on there, right? But anyway, I'll let you figure that out.